start off with the basics, there are three types of heat transfer: conduction, convection, and radiation. Conduction is the transfer of heat through a material by direct molecular contact. For example, you place a metallic spoon in a hot cup of tea. Over time, the metallic spoon tends to heat up. That's conduction. Convection is a transfer of heat through the movement of a fluid. For example, you want to cool down your hot cup of tea. You blow air on it, and that cools your cup of tea. That is convection. Radiation is a transfer of heat through electromagnetic waves. For example, you stand outside in the sun emits electromagnetic waves which ultimately heat you up through the process of radiation. Material thermal expansion is a phenomenon that occurs when a material expands or contracts due to the change in temperature. Here's the formula you need to memorize. Delta L equals to L into alpha into delta T, where delta L equals to the change in length, L equals to the original length, alpha equals to the coefficient of linear expansion, and delta T equals to the change in temperature. You could also have another formula that goes by delta R equals to R into alpha to delta T, where delta R equals to the change in radius of a circle, and R equals to the original radius of a circle. Now remember, metals tend to expand more than plastic simply because metals tend to have a higher coefficient of thermal expansion. Let's say I was an interviewer and I proposed to you a hypothetical rod which is roughly 5 meters long. I told you that it was originally at 20 degrees Celsius and I heated it up to 50 degrees Celsius. What would be the change in length after I heated it up to temperature Q? Well, again, this concept is relatively straightforward. You just use a coefficient of thermal expansion formula and you should be fine. The formula goes something like this: delta L equals to L into alpha into delta T. Delta L is your elongation length, which is what you're trying to solve for. L is your original length, coefficient of linear expansion based on what the material is. If let's say this is steel, based on the specific grade of the steel, you get a different coefficient of linear expansion. Just search it up online and get it. And your change in temperature. In our case, it's T2 minus T1, which is 15 degrees minus 9 degrees, ultimately giving us 30 degrees. So if you do the formula, delta L equals to 5 into your alpha, which is something you get online, into 30 degrees, you should basically get the delta L answer. I think the question is relatively straightforward. It's not so difficult. If you don't know the formula, why not? I know the formula. Well, anyway, yeah, this is all it is. Don't worry about it. That's all we need. The energy formula, Q equals to mcat, where Q equals to the amount of heat energy transferred when an object of a certain mass undergoes a change in temperature. Now remember, the key word is heat energy is transferred. You cannot create heat, it's always transferred from, let's say, mechanical to electrical heat. It's always transferred, not created. I made the mistake of saying energy was created accidentally, and I stuck to the point so much so that the interviewer cringed. I was like, what the hell are you saying? So yeah, that was pretty awkward, but don't do it. Q equals to mcat. Q is the heat energy transferred. M is the mass of the object. C is the specific heat capacity of the object, and delta T is a change in temperature. If you want to solve for power, that's simply work done per unit time, which is Q over T, or joules per second, or watts. Okay, so we have a container of water that is currently at 10 degrees Celsius. We don't know what the equilibrium temperature is, but we do know the volume of water as 1 liter. That helps. Now, in terms of steel, we have a steel block currently at 50 degrees Celsius. We have a side of 0.1 liters, which helps us find the volume, right? Because it's A cube and it's A cube, and therefore it's A cube as it says in the side cube. And then we have mass of 5 kg, which is great. So we do know that when steel is dipped in the water, the temperature of water will rise up and steel's temperature will decrease. Ultimately, the equilibrium temperature will be somewhere between 50 and 10 degrees Celsius. Now, what is that temperature? That's what we got to find, right? So we do know that heat is transferred from a higher temperature to lower temperature always. For example, let's say you held a piece of ice in your hand or your fingers, you start to feel cold in your fingers, not because the ice is cold. You feel cold because you're losing heat from your fingers to the ice block, ultimately melting the ice block. So heat always travels from high temperature to low temperature. In this case, heat travels out of the steel block into the water, which through the process of conduction, obviously. So since there's no other form of heat loss, we have Q of steel, which is the heat of steel or the energy of steel, equals to negative Q of water. Right? So negative Q because he is lost on one side, he's gaining the other side. That's what's happening. And we simply have that formula, mcat, mass into specific heat capacity and changing temperature, equals to negative mcat, mass into heat capacity into changing temperature for water. For water, it's for steel. You know the mass of steel is 5 kg. You know the specific heat capacity of steel. If you can search it up online and definitely find the heat capacity of the specific steel that probably we mentioned in the question. And finally, you'd have a change in temperature, which would start off with your T final minus your initial temperature, which is 50 degrees Celsius. For water, mass of water. Now, how do we solve for this? How do we do that? Well, we have this formula. We know what volume is. We know what the density of water is, obviously. And using this formula, density equals to mass or volume, it can solve for mass. Because we already know what the density of water is, and we already know what the volume of our water is here. Solve for our mass. So that's our mass. This is the heat capacity of water. We can search that up and get it. Change in temperature, again, would be T final minus 10 degrees Celsius. Now, since we have all the numbers ready with just one unknown, that's our TF or T equilibrium, we solve it and we're jumbling up the numbers together, playing around with it, and finally getting our T final, which would be the answer rate. That's how you'd solve this question. It's not too difficult. It's just a plug and chug with the formula that we have here, and that's kind of it. So here's a question I was asked during the interview. Why is aluminum bolted and not welded? Well, the answer is twofold. Aluminum tends to have a pretty high thermal conductivity, which means that it absorbs heat and dissipates it pretty quickly. So let's say you were to weld a side of aluminum. What aluminum would do in this case, let's say it was a part, would absorb that heat and dissipate it across the surface, ultimately distorting it or warping it or even causing curls to occur on the sides. Therefore, if you were to bolt it, I think it's a more controlled assembly process, making it a more effective process in general. The second reason would be difficulty in welding. Now, since aluminum has a comparatively lower melting point in comparison to that of steel, it tends to form an oxide layer on top, making it difficult to weld. I think it's aluminum oxide that's formed on top. That makes it an added level of difficulty in the entire welding process. That'd be your answer. Some ways to cool a heated enclosed chamber. Well, the first one would be to use a fan, right? It's the most obvious answer. Using the process of forced convection, the air that's blown from the fan hits the heated surface, carries that heat, and moves on with it. The second one would be to use heat sinks, or if you already have heat sinks, you could expand the area. Now, in order to explain this heat sink concept, you can use this formula called Q equals to H into A to delta T, where Q is the heat transfer rate for convection, H equals to the heat coefficient, A equals to surface area, and delta T equals to change in temperature. Now, as surface area increases, the heat transfer rate increases too, which is defined by joules over second. So yeah, this would be your second answer. The third one would be to use a thermoelectric cooling device, such as a Peltier device. And finally, if this device was an electrically enclosed chamber, you could reduce the amount of current that flows through the wire to reduce the heat, because heat generated is directly proportional to the amount of electricity or current that passes through a wire, and this occurs due to the internal resistance of the wire in the first place. So if you ever so choose to reduce the amount of heat, you can reduce the amount of current flowing to the wires itself. Now, I got this information from a very smart YouTuber, and yeah, thanks, man. Much appreciated. Another question was, why do railway tracks have spacing between them called rail gaps? Now, the simple answer to this is thermal expansion. And during the hot days of summer, the steel tracks tend to expand because of thermal expansion, and therefore it's essential to allocate space for these expansions to occur. If there wasn't any space, the two adjacent rail tracks would hit each other, where they would either warp upwards or downwards or just break path. Another question I was asked was, let's say you have a mercury-based thermometer and you dip it in hot water. Why does the thermometer level increase or decrease? Well, the answer again is thermal expansion. Mercury is a metal, and therefore, because of its coefficient of thermal expansion, it expands and contracts according to the temperature it's put in. So if you notice, there is a pattern to these thermodynamic questions. You just need to memorize these concepts and a couple of formulas, and then you can basically answer any version of these thermodynamic questions put forward to you. There's one more formula that you'd have to memorize before we end this video. It's the relationship between electricity and the amount of heat generated. Well, let's say we had a copper wire and we send some free-flowing electrons from one side of the wire to the other side. And obviously, because of the interaction between the atoms present inside the wire and the free-flowing electrons, there's friction, which ultimately results to heat generated, right? So how do we calculate the amount of heat that's present in this wire? So we use the formula P equals VI, which is power equals the voltage and the current. But we also know power equals the energy generated over time, right? So Q over T equals to VI. Now we know V also equals to current into resistance. Therefore, if you bring all of them together, you ultimately get the formula Q equals to I squared RT, where I is your current, R is your resistance, and T is your time. Make sure you memorize this formula. This will definitely come handy in your interviews. I was asked this question personally during the interview, so I would say it's pretty beneficial to learn. If you started off by talking about the 3 types of heat transfer, then the materials of thermal expansion, followed by the energy formula and some of its related concepts, and we finally concluded with some engineering questions. Now, I am fairly confident that you will get tested from at least a few concepts, if not many, from this very video series, so make sure you understand this video series pretty well. Final words of advice before ending this video: understand the concepts very well, memorize the formulas, and understand when to use those formulas. Understand the job description thoroughly and curate all your answers towards that job description. It'll help you a lot during your interview. And finally, don't stress out too much about the interview. It's a job interview, not a life interview. So yeah, if you get a job, that's great. If you don't get a job, that's a great learning experience, I'd say. I've been in the former and the latter, and I know what it is to not get a job. So don't worry about it. It's completely fine. You learn a lot, and it'll make you a better person all in all. So yeah, I wish you the very best in your future endeavors, and make sure to study hard. Good luck.